Right angle triangle. Agreed? All right angle triangles obey what? So let's do Pythagoras' theorem really quickly. What's it's 5x minus 9 by another 5x minus 9. I'm taking this one's fairly easy pickings for us. We're hoping, aren't we? So 8x squared minus 88x plus 80. Would you agree everything's divisible by 8? So I think I might turn that into x squared minus plus. Yeah, lads, like this would be a junior cert question and it'd be fair game. So they're occasionally they gift you some marks, you know. It's nice when that happens. Who got 10 and 1? Eventually. Now, if you think of 10 and 1, here's the problem with the number 1. You looking? What's 5 times 1 take away 9? What's 5 times 1 take away 9? What? Yeah. Can lengths ever be minus? So that means your number 1 is disqualified from being in. It's disqualified. So the only answer is actually 10. We go back up to the top and we put in 10, all right? And what happens when we put in 10? We get 9, 40, and 5 times 10 is 50. 50 take away 9. So we have 9, 40, and 41. Okay, I think that's what part B is about. So we're going to use x equals 10, and we're going to have 41 squared equals, was it 40 squared and, was it 9? Let's go back. Yeah. Okay, I'm just going to charge my, and here we go. So 41 squared. Yeah. 40 squared. And that one, 81. And because it balances, it confirms that it is a right angle triangle, and it is therefore a Pythagorean triple. Pythagorean triples are numbers that balance to make Pythagoras' theorem work. So 3, 4, 5 would be a classic example. 5 squared equals 4 squared plus 3 squared 25 equals 16 plus 9. Everybody know what Pythagorean triple is? Is there another part of this question? Ah, yes, this one. Show that it's an injective function. All right, I have an idea. Everybody get your table function out really quickly. Okay. And draw this line. Just draw the line. Start at like, I don't know, minus 3 to, I don't know, plus 3. Only draw a couple of points. You don't really need too many. All right, I'm gonna make some easy points for myself. Minus 1, minus 5. Where would that be located? 1 across and 5 down. Where's the next one then? 0 minus 2. Yeah. And 1, 1. What's the next one? 2, 4. I'm only drawing the ones that are easy to draw. I'm not going any further than 3, 7, to be honest. Are you cool with that? Now, when I draw this axis, I'm just going to go, you're 2, you're 4, you're 6. And I can say that that's 8. And I can say that that's 2, 4, and that's minus 2, and that's minus 4. For something to be injective, what is the horizontal? The horizontal line test means that An injective function, every input only has one. So each horizontal line has to hit at most once. And what can you say then? Horizontal line test. Every horizontal line only hits it at most once. That's what you say. So you'd write that down, yeah? Yeah. Every horizontal line hits it only at most once. Is that cool, you guys? Now, there is another thing. If it has an inverse, it's a, what was I reading a minute ago? If we remember from our revision, a bijective function is injective and it's perfect one-to-one, isn't it? And if you're bijective, you're also injective. So if an inverse exists, your function is automatically bijective. Therefore, it's also injective. As complicated as that sounds. Okay, you're going to have to probably revise what that means. But long story short, in injective functions, you're only allowed to hit your graph once. I think that's the easier one to do, isn't it? Yeah, that's the one I taught you, right? Now, let's go to part 2. Oh, deadly, we had to find the inverse anyway, didn't we? So let's find the inverse. Now, how do we do, what's the technique for inverses again? Get x on its own. So get x on its own. So how do you get x on its own? Y plus 2 equals. And then what do we do after that? Divide by 3, and what do we get? Y plus 2 all over. Do what's called a interchange. Interchange x for y and y for x. And long story short, your inverse function is now going to be what? X plus 2 all over 3. Is there any way of checking this out? Do you want to make a quick checking way? There's a way of checking this out. Think of an input. Pick a small input. 1. Now, if we put 1 into our original function, what does it turn into? Turns to 1, doesn't it? And if we put 1 into our inverse function, what does it have to turn back into? Because it's going to be 1 plus 2 over 3, which is 3 over 3, which is 1. Check it out for 2, just to make sure. What would 2 turn into? 3 times 2, take away 2. And if we replace this with 4, what would that turn back into? 6 over 3, which is? So this inverse function definitely works. Do you remember doing them? It's hard to remember every exercise though, isn't it? That's sometimes your problem, guys, if you don't mind me saying, is that you do the papers, but you don't check off every exercise in the chapter. So you either get lucky or you don't. Isn't that more or less it? Yeah, so unfortunately you'll need to use those notes I gave you and look through every exercise.